In today's lesson, we're going to discuss surveys, experiments, and observational studies and the differences between them and how you can differentiate them. There are different ways of collecting data. Surveys, experiments, and observational studies are some examples. So an experiment imposes a treatment on an individual to collect data on their response of a treatment. So basically an example of that is a researcher adds acetone to gasoline to measure its effects on fuel efficiency. And then an observational study observes individuals and measures variables without controlling the individuals or their environment in any way. So a researcher wants to find out if poor nutrition affects eyesight, but it would be unethical, obviously, to deliberately subject someone to some individuals to a poor nutrition. So that's when we would do an observational study, is when it's could cause health risks. So here's our first example. Explain whether the situation is an experiment or an observational study. So a researcher asks students the average number of hours of sleep they need to get per night and examines whether the amount of sleep affects the student's grades. Okay, so notice it says here that they ask and then they examine, right? Okay, so when we get over here and we start talking about how do we make a decision as to whether this is experimental or observational? So the keyword was asks, right? And then it's observational because they're just examining. So they ask and look at the grades versus doing an experiment in a lab where the data was recorded. So the next example says explain whether the situation again is experiment or observational. So a park employee wants to know if latex paint is more durable than non-latex paint. So she paints 50 benches with latex paint and 50 with non-latex paint. So here again, this one is obviously they paint 50 with and without. So this is an experiment because the park employee painted 50 with both. Our next one, a researcher wants to know if soil additive makes a fern grow more quickly. He grows one specimen in treated soil and one in untreated soil. So what do y'all think about this one? Keyword grows one of both. Yes, so it's an experiment. So the researcher applies a treatment. So basically, if one has the treatment and one doesn't, then that's when we're going to say it's an experiment. So the next one says to find out whether car accidents are more likely on rainy days, a researcher records the weather conditions during 50 randomly selected accidents for the past year. Okay, so here the keyword says records randomly selected. So this is going to be observational. Obviously, it would be really hard. As the nature of this is it's an accident, right? So the researcher just gathers the data without controlling the individuals or applying a treatment here. It couldn't even be called an accident if I controlled the situation. So that's why this one's observational. So for data from an experiment to be useful, the experiment must be carefully designed. In a controlled experiment, this is your blank, two groups are studied under identical conditions except for one variable. In a randomized comparative experiment, the individuals are assigned to two groups randomly, the control group, which does not receive the treatment, or the treatment group, which does receive the treatment. So again, we have two groups here, a treatment group, that one receives the treatment, and then the control group, and the controlled group does not receive the treatment, whatever that is. And we use that for comparison. So here's our first example. It says the study described in the report is a randomized comparative experiment. Describe the treatment group, and the control group. So it says here a faster website. So to test and redesign of a website. An online bookseller assembled 96 users of the site and randomly divided them into two groups. One group used the new website to make online purchase, and one group used the old website to do the same transaction. Users of the new site were able to complete the purchase 22% faster. So what are we looking at for here? So basically, they randomly divided them into two groups, right? One group used the new website, and one group used the old website. Ooh, I don't know what happened there. Kind of went wacky on me. Let's just do it in a different color. So the other one used the old website, right? So when we're talking about this one, the treatment is using the old versus the new website, right? So treatment group used the new website to make an online purchase, and the control group used the old website to make the online purchase. Okay, so that's what we're looking at there. So randomized comparative experiments allow us to make valid cause and effect conclusions. So these experiments are also very reliable and can be repeated over and over again and get similar results. So sometimes conducting an experiment would be unethical. Can you guys think of an example of that? There's lots of examples, but what if you were doing something with a child who couldn't make a decision for themselves? So if you put sunscreen on half the children and not sunscreen on the other half of children, would that not be unethical, because you could expose the children to sunburn, some of them. So in cases like this, you should use an observational study. So there still should be randomness though when you're talking about these studies, okay? So we're going to explain whether the research topic is best addressed through an experiment or an observational study, and then we're going to explain how we would set up the experiment or observational study. So does listening to an MP3 player, we'll just say some music device, right? Because most of y'all are doing that on your phones today with earphones or earpods for more than 1 hour per day affect a person's hearing. So would you guys do an experiment with this one, or would you do an observational study? And why? That is the question, okay? So on this one, we do an observational study. Why? Because we would choose people who do and do not listen to one more, and they would monitor their hearing. So if we were exposing people to more and it was going to affect their hearing, then we could be held liable for that. So that's why we would make it observational. This next one says, do people who consume 1,000 milligrams of vitamin C each day as a dietary supplement have a lower cholesterol level than people who do not consume vitamin C supplements? What do y'all think about this one? Experiment or observational? And then how would we set it up? Okay, so I would say experimental on this one. We don't know of any negative long-term effects of vitamin C, so we would probably do half. So we would choose one group of people to take the supplement and randomly choose another group of people to not take the supplement, half and half, and monitor the cholesterol levels of both, okay? So here's our last example. Does using tanning beds at least twice a month affect the likelihood of developing skin cancer? So would you do this experimental and observational? And how would you set it up? So here again, this would be observational. The treatment may affect their health, so it's not ethical to assign individuals to a treatment group. So we would perform an observational study. So randomly choose one group of people who already use tanning beds at least twice a month and another who does not, and monitor the incidence of skin cancer in both groups. All right, so here's our last example, and then we're going to do you try. A researcher is considering three methods of evaluating two different cold medicines. So tell whether each method is a survey experiment or an observational study. Then explain which method would be most reliable. So on this first one, it says choose 50 people at random, ask which cold medicine they have taken in the past and how effective it was. So we're asking them, right? I don't know what happened there. So because we're asking them, this would be a survey, wouldn't it? Okay. All right, let's talk about the next one. Monitor 50 people with colds and measure the length of the symptoms for the individual who chose to take each type of medicine. So on this one, they chose to take the medicine, right? We're still monitoring 50 people with colds, right? But they chose to take the type of medicine. So this, I would say, would be observational. Okay, and then the last one, randomly divide a group of 50 people with colds into two groups. Give each group a different medicine to measure the length of the symptoms. Okay, so on this one, we divided them. Whoa, I don't know what happened that time. I guess my pen is wigging out today, y'all. So we divided. Okay, I give up. I don't know what's going on. I think y'all understand. So basically, dividing into 50, the groups. Wow. Into two groups of would be what determines that this is going to be experimental. Let's see if it's going to write down here now. I don't know. Yeah, this one's experimental. Now, which one do you guys think would give you the most reliable data. Yep, experimental is always going to give you guys the most reliable data, okay, because it is got a control group. All right, let's see if you guys can do this last you try. Again, explain which method is being used and then which one is most reliable. So randomly choose 50 people to exercise 3 hours a week and 50 people to participate in another activity and monitor their health. So this one I would say is experimental. Why? Because you had 50 and 50, okay? And then method B, randomly choose 100 people, ask how many hours a week they exercise and how healthy they are. So this is an ask question, so this would be a survey. And then the last one, choose 50 people who exercise regularly and 50 who do not and monitor their health. So because we chose here, this is going to be observational. If I could spell it, be good. Which one of these is most reliable? Experimental.